You are designing a storage architecture for a Google Cloud project that must adhere to strict data residency requirements for a single geographic region. The project needs to store data, archive it after 30 days, and ensure that the archived data is accessible once every year. What strategy should you implement?
Option A. Use multi-regional storage and configure a lifecycle policy to move objects to cold line storage after 30 days. Option B. Use multi-regional storage and configure a lifecycle policy to move objects to nearline storage after 30 days. Option C. Use regional storage and configure a lifecycle policy to move objects to nearline storage after 30 days. Option D. Use regional storage and configure a lifecycle policy to move objects to cold line storage after 30 days. This scenario tests your ability to match Google Cloud storage classes and location types to specific compliance, access, and budgetary requirements.
When evaluating these options, consider how data location impacts residency compliance and how access frequency dictates the most cost-effective storage class for long-term archival.
I believe the correct answer is option D. Use regional storage and configure a lifecycle policy to move objects to cold line storage after 30 days. The primary driver here is the strict data residency requirement. Because the project mandates that data must reside in a single geographic location, you must use regional storage. Multi-regional storage automatically replicates data across multiple geographic areas, which would violate your compliance mandate. This immediately eliminates options A and B.
Regarding the choice between storage classes, nearline storage is typically optimized for data accessed about once a month. Since your requirement specifies that the archive data will only be accessed once per year, cold line storage is the much more cost-effective solution. Consequently, using regional storage to satisfy residency, combined with a lifecycle transition to cold line storage to minimize costs for infrequent access, provides the optimal architecture for this requirement.